Hey everybody, in this video, we are kicking off Chapter 1, Section 6. The title is Other Types of Equations and Applications. A lot of this stuff is going to be stuff that we've already touched on in Chapter R and the whole entire first 5 sections of Chapter 1. We've been, working into this. We're just going to formalize it and really tie it all together and put a bow on it in this section here. Some of it will be formalized for the first time for some of you guys. So just buckle up, make sure you're paying attention. You're not just here as an observer, you are a participator. You are trying these questions, you're pressing pause, you're trying it and then pressing play and seeing did you do it correctly, right? You're always diving in and seeing what you can do and what you can understand. Now, these are rational equations that we're going to look up first. I'm going to break it up into two videos, part A and part B. Rational equations are exactly what they sound like. They are equations that include the ratios, right? So the thing that makes a rational expression is the having x in the denominator. So this one here, that is a rational expression, whereas this one here is actually a linear expression. That's x minus 1/3. And then this is also linear. So we'll have linear expressions perhaps built into it as well, but it's having that x in the denominator that is unique to this situation. So we want to basically solve this by what we're going to do is something we've seen already in some of our problems that we've been solving. And that is we're going to clear out our denominators, but you must remember your roots. You got to remember where you came from. So looking at this immediately, I'm going to state my restrictions here. X can't equal 1, and you don't want to forget that. So at the end, if you get an answer and one of your answers or the only answer is 1, you need to throw that answer out, exclude it, because that answer would be what we call extraneous. So the first part of this word is saying extra. So it's like an extra solution, because what happens is when we end up clearing out our fractions, right? Actually, I can put that back. When we clear out our fractions here, we are going to turn this rational equation into a polynomial equation. The domain of a polynomial equation is all real numbers. There are no restrictions. So by changing the type of equation that it is, we're kind of patching up all the holes and breaks and putting duct tape on it. And we're like, don't worry, there's no problems here. But really, at the root of it, the original equation, there are certain restrictions that we can't have certain values. So we want to keep your restrictions in mind. Anyhow, so let's go ahead and start this problem. So I'm going to see here, I have a rational equation. I'm going to multiply through on both sides by my lowest common denominator. My lowest common denominator would be 3 times x minus 1. This will end up multiplying on both sides. So here I have the 3, here is the x minus 1, and that's just the 1, so it don't matter too much, right? So if we distribute that into everything, so when I go and distribute that into this first thing here, the 3's reduce out, they're gone. What am I left with? I'm left with the 3x minus 1, which was up there to begin with, and it's going to be joined with x minus 1. Then I have this minus sign. So again, 3x minus 1 was original and x minus 1 being distributed. Okay, minus sign. 2x was originally there. When I distribute this thing right here to that fraction, the x minus 1's will cross out, reduce out, they are gone. And I am left with 2x times 3. Then we have this equal sign, and we're going to distribute to the x right over here, but there's nothing to cross out. So that means that the 3 is going to join the x. I'm just going to kind of write it like that. And x minus 1 is going to join as well. Now, this equation that started off as a rational equation no longer is rational. It is now a polynomial. So I'm going to have to do what? Well, I'm going to have to expand, clean it up, combine like terms. And if it's linear, well, that's great. We could just go ahead and solve easy peasy lemon squeezy. If it is quadratic or higher degree, we're going to get it equal to 0 and work on some factoring, okay? So here I'm going to distribute. I get 3x squared. Outer is minus 3x minus x, so it's minus 4x. Negative 1 is plus 1. Minus, this is 6x equals 3x times x, so that's 3x squared minus 3x x. That should be no problem. If that's difficult for you, you may want to take a good look at what's going on and why you think that's hard. Are you practicing and do you know your fundamentals, right? Okay, from here, if I subtract 3x squared, it's going to disappear. I have a negative 4x, I have negative 6x, well, that's negative 10x plus 1. And we have negative 3x over there. If I add 10x to both sides, I'll have a 1 here, and I'll have 7x there. Divide by 7, and I get that x equals 1/7. It was linear. That worked out pretty nicely for us. 1/7 is an acceptable solution because it is not 1. And 1 is the only restriction. So we are good to go. And that is your only answer, okay? So 1/7 is the solution. But remember, we turn this rational into a polynomial. Polynomial has a domain of all real numbers. So we always got to double check that the answers we get satisfy the original problem, because the manipulation of the problem is just a solving technique. It doesn't mean that that original problem no longer exists. Okay. So I'm going to do part B in a separate video so I can keep these into little short pieces. Hopefully this was beneficial to you. You followed it. You understand. If you simply think you understand, I need you to try the next one before watching the video. If you don't have it done already, try it and then watch, okay? Just be honest with yourself. Stop lying to yourself and say, yeah, I totally would have gotten that when you wouldn't, okay? You, first step is admitting that you have a problem or that, certain things are not as easy as you thought, okay? So the playlist will be on the screen at the end of this video. Or you could maybe easier navigate it in the description box below. Adios.